In this question here, I'm asking you to propose a synthesis of 2-iodobutane, this structure right here, from butane. What that means is that all the carbons in this final product, they must come from butane, which makes sense for this one. It's a 4-carbon chain in the product, and we have a 4-carbon chain to start with. All right, so you can use any other organic reagents needed, but all of the carbons in the final product must come from butane. All right, so I'm going to give you a piece of advice. I probably already said this a few times. When you're doing a synthesis question, you always want to work backwards from the product to the permitted starting material. And I know there's people out there right now who are saying, but why do that? It's much easier for me to go from the starting material to the product. That is true right now because we don't have, at this point in the book, we don't have a lot of reactions under our belt. But trust me, I know you don't know me, but I'm going to give you a piece of advice. Do these backwards always, because what's going to happen is in the future, when you have a lot more reactions under your belt and you're dealing with things like protecting groups and having functional groups that react with other reagents, these become problems. So if you're trying to go from the beginning to the end, you're going to run into a lot of problems. If you're going backwards, you're going to go one step at a time. All right. So just trust me when I say work backwards from the product. It'll make much more sense later and it'll make your life easier. All right. So the goal here is if I have 2-iodobutane, I'm just going to keep asking myself, how can I make this and what can I make it from? All right. So I'm going to draw this arrow backwards because again, I'm asking myself how to make this thing and what I can make it from. All right. We don't know at this point in the book, we don't know a good way to directly put the iodine atom on a hydrocarbon like butane. We don't have a way to do that. But we do know that we can use the iodide ion in the form of potassium iodide or sodium iodide. I'm just not drawing the cation there. I can do that in an aprotic solvent like acetone, so I'm just drawing acetone there. I know I can put that on there by doing an SN2 reaction. But in an SN2 reaction, this reagent here needs to have a good leaving group specifically on one of those secondary carbons. So I had to have had a good leaving group here. Now, I'm thinking ahead a little bit and I'm putting bromine there. Could you have put chlorine there? Yes. Is it the best answer? No. Bromine's the better answer here, and I will explain why. All right. So we know that iodide could come in, tack that carbon, kick out that bromine group, and then we substituted the bromine, the iodine in the bromine's position. All right, so the next question I'm asking myself is, how can I make 2-bromobutane? Can I make it directly from butane? And we know that we can, right? We can use bromine in the presence of an initiator like heat or UV light. And that'll do the radical reaction where it will put the bromine mostly in the secondary position. Okay, so that is why I used bromine here and not chlorine, because I want the bromine, I want whatever the leaving group is, I want it to end up in the secondary position. So you might be saying to yourself, well, if I use butane and I react it with chlorine and UV light, don't I get 2-chlorobutane? Yes, you do, but you also get 1-chlorobutane, okay? And there's no real controlling which one you're going to get in the majority. And remember, when you're trying to synthesize something, you want to maximize the amount of your desired product here. So if I want that bromine in the secondary position, why don't I just use something that will mostly put the leaving group in the secondary position? Doing it this way would be considered wasteful because I don't need a leaving group in this primary position. So that is why I chose bromine there. All right, so this here would be a good synthesis for forming 2-iodobutane from butane.